Hello students, in this video I will go through exercise U3A06A, which is the direct application of the perpendicular and angle bisector theorem. And we are going to use those theorems to solve problems. Okay, so what exactly is the perpendicular bisector theorem? Let's just recap what that is. So the perpendicular bisector theorem just states that if I have a line passing through a line segment and it bisects the line segment and it comes perpendicularly, it is said that all of these points are going to be equal and distant to those two endpoints. And it just so happens that all of these angles will then end up being the same. All of these side lengths are also going to be the same on either side of that bisector. Okay. And the other thing about the angle bisector is that in an angle bisector, all of the points, okay, that are directly going through that vertex there, they are going to be, again, equal and distant, okay, to the sides of that, to the sides that form that angle. So all of these lengths are going to be the same. These angles over here are going to be the same. So that's, in a nutshell, the perpendicular and angle bisector theorem. So let's take a look at how we can approach this. So here, in this case, this is going to be the setup for which one? Is it the angle bisector or is it the perpendicular bisector theorem? The way that this is set up, this is actually going to be the perpendicular bisector. And how do I know that? Well, that's because WZ is congruent to ZY. That segment, WY, is bisected, and it's perpendicular. This line is perpendicular to that segment. That's how I can tell. So if that's the case, this side over here must also be 12. So that's it. I'm asked to solve for what XW is. Let's take a look at number 2. In this case, this is again a perpendicular bisector because these two sides are the same. So if those two sides are the same, that means these two sides are going to be the same. And if those two sides are going to be the same, then these angles over here are also going to be the same, and these angles over here are also going to be the same. So anyway, AC is going to be equal to 14. Question number 3. Is this a perpendicular bisector or is it an angle bisector? So for question 13, this is indeed, again, going to be a perpendicular bisector. Sorry for the text looking a little strange here, but this is 10x minus 5. And this is 7x plus 1. Anyhow, so the question is to find out what LP is. Since this is a perpendicular bisector, those two segments, left and right, are going to end up being the same. 10x minus 5 is equal to 7x plus 1. Subtract 7x, I get 3x. Add 5 to both sides, I get 6. Divide by 3, I get x is equal to 2. Since x is equal to 2, I can then figure out what LP is. LP, therefore, is equal to 10 times 2 minus 5, or it's really equal to 15. Moving on, question number 5. This is going to be an angle bisector, and how do I know that? Well, that's because the angle over here is bisected. And if that's the case, the distance that the point is away from the sides of the angle are also going to be the same. So therefore I can say that CP is therefore also equal to, I think that is an 8. It's also going to equal to 8 since AP is equal to 8. AP is equal to CP, which is equal to 8. This is again another angle bisector. Since I have the distance between this point here to the sides of the that form the angle is a distance of 4 on either side. This is an angle bisector, so therefore this must be 23 degrees. Next, I have angle WYZ. Did I answer the question? WYZ. Yes, I did. So this is 23. Okay, here again I'm asked to answer for WYZ. Wait, this is the same question, so I don't need to do that twice. Number 9, NP. I'm asked to find out what NP is. So NP, this is a perpendicular bisector. How do I know that again? Because these two sides are bisected, and here I have a perpendicular. So therefore I can say that 2x minus 4 is equal to x plus 6. Subtract x from both sides, add 4 from both sides, I get x is equal to 10. Since x is equal to 10, I can then figure out what NP is. NP therefore is equal to 16. Moving on, question number 10. I need to find out what PS is. So since PS, well, this is again a perpendicular bisector because both of these are the same. They both measure 7 apiece. This is 7. And since this side over here is 9, the other side must be 9 as well. So PS is equal to 9. Moving on, KL. So this is again a perpendicular bisector. How do I know that? Because the two sides over here are the same. This is a perpendicular. The segment KL will be bisected. So KL will equal to half of 12, which is 6. EG, what will EG equal to? EG will be double FG. Since both sides here are equal to 6.5 apiece, this is both 6.5 apiece. And again, I apologize for the really ugly looking text here. EG is going to equal to 5. Okay. Next, this is again a perpendicular bisector. So BC is equal to CD, which is equal to 4. Number 14, this is again a perpendicular bisector, so therefore I can say 4x minus 4 is equal to 2x plus 2. Subtract 2x from both sides, add 4 for both sides, divide by 2 from both sides. I end up with x is equal to 3. Since x is equal to 3, I can then solve for what SW is. Well, I want to solve for ST first. ST is equal to 2 times 3 plus 2, which is equal to 8. And since SW is double ST, SW will equal to 16. All right, moving on. I need to find out what AF is. What is AF? All right, so this is an angle bisector. So because it's an angle bisector, these two angles are the same. The distance at this point is away from either side of the angle is going to also be the same. So AF is equal to 11. Question 22, DBA. I need to find out what angle DBA is. This is again an angle bisector because point D is equal in distance to both sides of the angle. So therefore angle DBA is also going to equal to 17 degrees. Angle PNM. So angle PNM is going to be half of, or actually not half of, double one side of that angle. Both sides of that angle is supposed to be the same. So 3x plus 5 is equal to 4x minus 8. This is a diagram, again, portraying an angle bisector. I want to subtract both sides by 3x, add both sides by 8, I end up with x is equal to 13. Since x is equal to 13, I can then solve for one of the angle on one of the side here, and then I can double it to figure out what angle P and M is. So 4 times 13 minus 8, what will that turn into? So that's 42 minus 8, which turns out to be 34. So double that would be 68. So angle P and M is 68. This is again another angle bisector. Here I'm asked to solve for what side length XA is. It's going to be the same as angle ZA. I'm asked to find out what angle PQS is. PQS is going to be half of PQR. So since angle 48, this angle on the outside is 48 degrees, and according to the exterior angle theorem, 48, wait a second here. Oh, wait. This angle, again, I apologize for the ugly looking diagram. That angle in there is 48 degrees. So if this angle inside is 48 degrees, then that means this angle here should be 48. Well, it's got to be 180 minus 90 minus 48, right? So that's 180 minus 138. So that's 42. And I'm asked to find out what PQS is. PQS is going to be the same as RQS, which is also 42. 26. PN. Okay, so this is again an angle bisector. So therefore LP is going to be the same thing as NP. So 3x plus 6 is equal to 4x minus 2. Subtract 3x from both sides, add 2 from both sides, x is equal to 8. So if x is equal to 8, I can then find out what NP is. NP is equal to 4 times 8 minus 2, which is equal to 30. All right. Next, it says determine if there is enough information in the diagram to solve for x. If there isn't, say not enough information. If there is, solve for it. Okay, so in this case here, let's see. Is there enough information to show for us to be able to solve for x? So this is also going to be 90. This is going to be 90. It does not specify whether or not this angle over here is the same as that angle. It doesn't specify whether or not this side is the same as that side. Because it doesn't, the diagram can be actually drawn in this manner. Right? In which case, we have no idea. We cannot use the perpendicular perpendicular bisector or angle bisector theorem. So not enough information. Let's see here. These two angles are the same. However, because we have no idea whether or not these are right angles or not, right? Because the diagram can very well be drawn in this manner. Let me just demonstrate this. That those two angles are the same. It could be drawn in this manner here. Actually, make it more apparent. So this could be 5 and then that could be x. There's no way for us to tell what that angle is. So again, this is not enough. Okay, can we tell with this? No, we cannot tell anything because the diagram can end up looking like this. We cannot say that x is equal to 7. We have no idea what that is. So again, this is not enough. And what about this? This is again going to be not enough because we don't know whether or not these two sides are the same. Right. We have no idea. The diagram could very well be drawn in this manner. And we have no idea of telling. Right? We have no idea. So again, all of these are not enough.